Mammals have complex biological systems and are constantly prone to infections by a wide array of bacteria, fungi, viruses, and parasites, a significant challenge to the constant development of disease strains resistance to current drugs. 1 As a result, there is always a need to identify new anti-infective agents against these organisms. An anti-infective agent is defined by Webster as an agent capable of acting against an infection, by inhibiting the spread of an infectious agent or by killing the infectious agent outright. 2 Some of the emerging and drug-resistant infectious diseases having research priority are human immunodeficiency virus, HIV, or AIDS, hepatitis B and C viruses, respiratory infections such as influenza and respiratory syncytial virus, RSV, and dengue fever. 1 Figures 1 and 2 provide us with the data in regards to the mortality and incidence rates, respectively, of people with viral diseases. Although there are many drugs available commercially from synthetic sources, limitations including drug resistance, side effects, cell toxicity, and long-term drug treatment are all possible explanations for the failure of the previously mentioned anti-HIV drugs. In addition, the evolution and development of nucleoside antivirals reveal the tremendous potential marine products have for the identification of novel prototypes, and also reveals the necessity of developing drugs from natural resources such as the marine environment. Marine species cover over 2/3 of the planet, making them a significant source for the production of novel compounds with possibly fewer adverse effects and higher inhibition activity. The compounds obtained from marine sources that are discussed in the following sections were found to possess anti-HIV-1 activity. Although there are many drugs available commercially from synthetic sources, limitations including drug resistance, side effects, cell toxicity, and long-term drug treatment are all possible explanations for the failure of the previously mentioned anti-HIV drugs. In addition, the evolution and development of nucleoside antivirals reveal the tremendous potential marine products have for the identification of novel prototypes, and also reveals the necessity of developing drugs from natural resources such as the marine environment. Marine species cover over 2/3 of the planet, making them a significant source for the production of novel compounds with possibly fewer adverse effects and higher inhibition activity. The compounds obtained from marine sources that are discussed in the following sections were found to possess anti-HIV-1 activity. Fluorotannins are tannin derivatives that were isolated from brown algae and are biosynthesized by the polymerization of the fluoroglucinol monomer units acquired from the pathway of acetoacetyl. These are highly water-soluble compounds. 225, 226 They can be classified into 4 different categories: fluorotannins containing an ether linkage, fuelols and fluorothols, phenyl linkage, fucols, phenyl and ether linkage, fucofluoroethols, and dibenzodioxin linkage, ecols. 227-8, for diecol, 88, and 8-bicol, 87, are isolated from Eclonia cava, a brown algae, and show inhibitory activity on HIV-1 reverse transcriptase and protease at inhibitory concentration, IC50, values of 5.3 and 0.5 μm, respectively. 228 This is due to the inhibition of the GP41 6-helix bundle formation. 229, 236, 6-bicol, 89, a natural derivate in Eclonia cava, possesses lytic effects, causes P24 antigen production, and has inhibitory activity against HIV-1-induced syncytia formation. It showed selective inhibition against the HIV-1 entry and the activity of HIV-1 reverse transcriptase enzyme at an IC50 of 1.07 μm. 231 Difluorethahydroxycarmelol, 90, derived from Ishijoka muri, also possessed inhibitory activity against HIV-1. It inhibits HIV-1 reverse transcriptase and integrase at IC50 values of 9.1 and 25.2 μm, respectively, figure 30. Galactone sulfate, GS, a polysaccharide isolated from Agardhela tenera, a red seaweed, showed activity against HIV-1 and HIV-2 at IC50 values of 0.5 and 0.05 μg/L, respectively. GS prevents the binding of HIV-1 to cells along with the binding of anti-GP120 mAb to HIV-1 GP120. It is also known to be active against enveloped viruses including togaviruses, arenaviruses, herpes viruses, and others. 256 carrageenans are extracted mainly from certain genera of red seaweeds that include Hypnea, Euchima, Jagartina, and Chondrus. Yamada and co-workers reported anti-HIV activity for oacylated carrageenan polysaccharides with various molecular weights, by means of sulfation and depolymerization. Calcium spirulin, CASP, a sulfated polysaccharide isolated from the marine blue-green alga Arthrospora platensis, showed potent anti-HIV-1 activity at an IC50 value of 2,900 μg/ml and reduced viral replication at ED50 values of 11.4 and 2.3 μg/ml. CASP is also known to inhibit the viral replication of other viruses that include HCMV, measles, polio, and Coxsackie virus by preventing the penetration of the virus into the host cells. 259 Xian et al. Reported 911. A marine polysaccharide derived from alginate that inhibited the HIV replication both in vivo and in vitro, attributing to the inhibition of the viral reverse transcriptase, interfering with the viral adsorption, and enhancing immune function. 261 Wu et al. Reported the inhibitory effects of the marine shellfish polysaccharides from 7 different shellfish, including Meritrix luzoria, Meritrix petechialis, Ruditapes philippinerum, Cynonovacula constricta Lamarck, Scapharca subcrenata, Scapharca bratonii, and Middleus coruscus, against HIV-1 in vitro by inhibiting the viral fusion GP120/GP41 with the CD4 protein on the T lymphocyte surface.